Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru, au piano. Bravo et merci.
All right. So here we are at the finals. This is the ultimate matchup between Luke and Maxim. There will be 5 integrals, and these integrals will be hard. The time limit is now 4 minutes. And at the end of the 5 integrals, maybe sooner, maybe later, we'll see who is the grand integrator of 2023. Indeed, good luck to both competitors. The first integral of the finals. Are both competitors ready? All right. 3, 2, 1, integrate. Two minutes. 30 seconds. Ten seconds. Time is up.
What is that thing?
Okay, the answer is 2 root 3 pi over 9. At least you guys both got the pi part right. Okay, let's move on to the next problem. The score is 0-0. All right. Are both competitors ready? All right. 3, 2, 1. Integrate. Two minutes. 30 seconds. Ten seconds. Time is up. The answer to this integral is 7 pi.
Nice try.
Very valiant efforts. But unfortunately, the score is still 0-0. We move on to the third integral of the finals.
Oh, the whole thing is square.
All right. Are both competitors ready? 3, 2, 1, integrate. Two minutes. 30 seconds. Ten seconds. Time is up. We will check, but the answer is.
Oh, yeah, that's not what I said.
Hang on. We need to check. This needs to.
This actually needs checking. Looks kind of wrongish, but
We'll double check Maxim's answer. So hang tight. It seems like it's close, but no cigar. Therefore, we move on to problem 4.
the score's still 0-0.
The score is nil.
And there are 2 questions.
There are 2 problems left. Until either a winner is decided or we go to tiebreakers. All right, are both competitors ready? 3, 2, 1, integrate. Whoops. Did you see anything?
I saw it had a big number in the
I can scroll too far, but I'm not sure Luke saw it. Keep going for now. Sure. Oh, just a clarification, you are not allowed to have floor functions in your answer. "45 seconds. But the intended answer, sorry about the mishap, but the intended answer is, yeah, it shouldn't be a multiple of 5, so it seems like both people got it wrong. As I said, these are indeed tough integrals. We'll move on to the last integral. Last integral of the regular matchup. And Luke, just for future reference, please look at the integral in your hand and inside of the screen. Yeah, the screen is for the audience. Sorry. Yeah. Okay. Don't look at the screen. Yeah, just in case I mess up again. All right. Integral 5 of the finals. Are both competitors ready? Yeah, after I scroll over. Yeah, sorry. Yeah, all right. 3, 2, 1, integrate. Luke, the answer is 27/32. Luke has the answer correct. The answer is, time is up. All right, this is the moment of truth. The answer is 27/32. Luke has the answer correct.
The roll that was wrong earlier was missing a factor of 2, if you want to just quickly display that again.
So,
I don't remember which one it was, though.
so the integral that was
It was just missing a 1/2.
in semifinals.
Yeah, it was just a typo.
Okay, so there's an errata from the semifinals. Let me pull it up.
I think it's semifinal 2, but yeah.
Does it affect anything?
No. They were both wrong anyways.
Okay, so back in semifinal number to number 1, our answer is off by a factor 2.
It's 1/2.
There should be 1/2 over in front of everything. Just FYI. Yeah, when we publish all the questions on the website, we'll be fixing the errors. But for now, let's congratulate Luke for becoming the Grand Integrator of 2023. And also congratulations to Maxim for being the runner-up. It has been an awesome match. The competitors have been awesome. The integrals are hard, but they stood up to them. And we'll be handing out the prizes afterwards. So, and feel free to stay here if you want to see some integrals being explained. But for now, that is it for today. Thank you, good night, and see you next year.
Is succession. Succession is just adding 1 to a number. The level above is addition. Addition is repeated succession. A plus b is equal to adding 1 to a b times. Then we have multiplication. Multiplication is repeated addition. A times b is equal to adding a to itself b times. Level above multiplication is exponentiation. Exponentiation is repeated multiplication. A to the power of b is equal to a multiplied by itself b times. The next operation probably many people didn't hear about. Tetration. Tetration is repeated exponentiation. A tetrated to b is equal to a raised to the power of itself b times. In other words, it is a tower of exponents with a height of b. Tetration is a very powerful operation that can generate incredibly large numbers. For example, 3 tetrated to 4 is a tower of 4 threes. To evaluate the tetration, we always start from the top. So 3 to the power of 3 is 27. 3 to the power of 27 is already equal to more than 7 trillion. Multiplying 3 by itself this many times results in a gigantic number. This number has over 3 trillion digits. With just the number 3 and 4, tetration can create numbers that are so enormous that it's hard for us even to imagine them. But tetration doesn't always have to generate numbers this big. 1 tetrated to any number is always a 1. Even if we have an infinite tower of 1s, it's still just 1. This is a trivial example, but now consider an infinite tower of square roots of 2. We can write it as the square root of 2 tetrated to infinity. But a more accurate way to express it would be using a limit as x approaches infinity of the square root of 2 tetrated to x. Surprisingly, this infinite tower converges to 2. The limit exists when we tetrate a number that's between e to the power of minus e and e to the power of 1 over e, which is an interval from around 0.07 to 1.44. The square root of 2 falls within this range. So far, we have written tetration using the left exponent. Unfortunately, there is no standard notation for tetration, but 2 up arrows are used very often, and this notation will allow us to express even higher level operations beyond tetration. The arrow notation can be also used to write exponentiation. A to the power of b can be written as a up arrow b. With this notation, we can define an operation on level 5. Using 3 arrows, we denote pentation. Just like tetration is repeated exponentiation, Pentation is repeated tetration. A pentated to b is equal to a tetrated to itself, b times. 3 pentated to 3 is equal to 3 tetrated to 3 tetrated to 3, and 3 tetrated to 3 is equal to 3 to the power of 3 to the power of 3, and that is equal to more than 7 trillion. And 3 tetrated to this number is a tower of 3s of height more than 7 trillion. This number is unimaginably massive. But we can go a level higher. With 4 arrows we can denote hexation. Hexation is repeated pentation. 3 hexated to 3 is equal to 3 pentated to 3 pentated to 3. This number can't be compared to anything in the real world. With this giant number, we can start creating the Graham's number, which is one of the most famous big numbers. To construct it, we start by defining that 3 hexated to 3 is equal to G0. Hexation is denoted using only 4 arrows and already generates enormous numbers. But G1 is equal to 3 followed by G0 number of arrows and another 3. Just imagine how big this number is. Next we have G2, which is denoted using G1 number of arrows. G3 is equal to 3, G2 number of arrows and 3. This sequence continues until we get to the G63, which is equal to 3 followed by G62 arrows and 3. That is the Graham's number. Graham's number was used by Ronald Graham as a simplified explanation of the upper bounds of the problem he was working on. At the time of its introduction, it was the largest specific positive integer ever to have been used in a published mathematical proof. In 1980, Graham's number was described in the Guinness Book of World Records. Since then, many bigger numbers have appeared in mathematical proofs. For example, the Graham's number is extremely small in comparison to the tree of 3. To explain what this number is, we need to play a game of trees. In this game, we try to create a forest using colored seeds, following 2 rules. The nth tree can't have more than n seeds. The first tree can have only 1 seed, the next can have more than 2, and so on. The second rule is that when you try to build a tree, it cannot contain any of the earlier trees within itself. For example, this tree contains this one, so it cannot be built. Also, the tree is contained in another tree when they preserve the nearest common ancestor rule. In this tree, the nearest common ancestor of the yellow and red seeds is the green seed. In the other tree, the nearest common ancestor of the yellow and red seeds is also the green seed. It means that the first tree is contained in the second tree, so the second tree cannot be built. The tree of n function tells us how many trees we can build using n colors of seeds. Using 1 color we can only build 1 tree, because the first tree will have 1 seed and any further trees would contain this tree, so tree of 1 is equal to 1. When we have 2 colors of seeds, red and green, the first tree has 1 red seed, the next can't have any red seeds because it would contain the first tree, so we can use 2 green seeds. To build the next tree, we still can't use the red seeds, we also can't use more than 2 green seeds. But the third tree can have at most 3 seeds, so it can have only 1 seed, and it can only be a green seed to not contain any of the previous trees. We can't build any more trees, so tree of 2 is equal to 3. Using 3 colors of seeds, we start with a tree that has only 1 seed. Then we can have this tree, then another one, and all of them obey the rules of the game. And we can go on, and build more and more trees. The total number of trees we can build using 3 colors of seeds is equal to tree of 3. This number is massive even when compared to Graham's number, but we know that it is finite. Graham's number, denoted as G63, is a colossal number, but we don't have to stop at G63. We can keep going. G64 is defined as 3 followed by G63 arrows and another 3. We can even create numbers like G100, G1000, or even G1 million. But none of them would even come close to the tree of 3. We know that tree of 3 is a lot bigger than G3 followed by this many arrows and another 3. The tree function generates incredibly massive numbers. Tree of 4 is already a lot bigger than tree of 3. We can put any number into the tree function. Just imagine how big would be 3 of Graham's number, or 3 of 3 of 3, or 3 of 3 of Graham's number. These numbers are beyond our comprehension in terms of size. Have at most 3 G3.
享受精彩，我只要白兰氏叶黄素冻，领先再升级，新添加智利酒果，水量舒适，一起精彩，强化型新上市，你也来试试。
Tetrated to this number is a tower of threes of height more than 7 trillion. Using 3 arrows will allow us to achieve 44. Surprisingly, we can these big digits. With just the number 3 and 4, tetration can create numbers that are so enormous that
YouTube Music 有多种情境的播放清单，像是你在跟深蹲奋斗的时候，试试 YouTube Music Premium。
Bravo mesdemoiselles, Camille Thomas nommée cette année dans la catégorie Révélation soliste instrumentale et Béatrice Berru, piano. Bravo et merci.
超过8000万首官方歌曲，让你永远不需要重复听相同的歌曲。试试 YouTube Music Premium。YouTube Music Premium 让你完整掌控你的音乐聆听体验，享受零广告，下载音乐并离线。
発想がハリネズミと一緒。
もうビオラってば、それって私が考えた対策じゃない。
A few months ago, I made a video about a difficult Turkish exam question, and that video seemed to resonate with a lot of people. There were comments in Turkish that were glad that people could see the pain that they had to go through, and there were plenty of comments lamenting the state of the education system. Let me show you some of the comments that gained a lot of support. This one translates to, "You only have a black pen, but create a rainbow." This is a summary of the Turkish education system. And this one says that the questions are of high quality, but unfortunately there is no system that will take us to the answers of those questions. Now, I have never studied in Turkey and I don't know enough to agree or disagree with these statements, but they do relate to a larger sentiment that we see in many other countries, and that is that the exam is not the challenge. The real challenge is competing against the other students. The exam in question is the AYT paper used to gain entrance into Turkish universities. The population of Turkey is 85 million, and over 2 million students are taking this test, hoping to be in the top 50,000 to get into the good universities. When entry is so competitive, you see exams getting harder to try and separate people, but many are left feeling frustrated by the fact that making exams harder doesn't raise the quality of education, and instead can leave students feeling dejected and hating school. This comment said geography is destiny, and this one said may God help Turkish, Indian and South Korean students, assumably talking about the tough exams they all have. Another common thread was people saying that even if you're lucky enough to ace this exam, get into a good university and graduate, that there are still not many jobs waiting for you at the end. This OECD unemployment rate data does show that Turkey has a pretty high unemployment rate. The latest figures are around 11.2%, whilst the USA and the UK are at 4% and Australia 4.2%. It also seems like a lot of the top students aspire to go overseas, contributing to what they call brain drain, where a country's brightest people aren't sticking around to help it grow. I plan to work through another one of the tough questions from the AYT exam paper, and I will get to doing that in this video, but first I got distracted by another comment that told me to check out the LGS exam given to middle schoolers in Turkey as a high school entrance exam. It is very hard. A math question this year was taken from the university exam. They are literally forcing students to solve university level questions at age 13 to 14. So naturally I wanted to take a look. Here's the paper, and yes, it's really hard. Apparently students studying for this are putting in 8+ hour study days, making it the youngest example of that kind of hard work I've seen for an exam yet. Let's take a look at the last question on the math section. We've got these pie charts which show the distribution of televisions sold in an electronics store in 2019 and 2020. K, L and M are 3 different types of televisions. It says that while the number of L brand televisions sold in the store in 2020 decreased by 25 compared to 2019, the M brand televisions increased in number by 40. According to this, what is the number of K brand televisions sold in 2019? So we want to know how many televisions does this slice of pie represent? That would be easy to do if, for example, we knew how many televisions were sold in total, either in 2019 or 2020, but that's not information that we have. So this becomes quite tricky. Please do have a go at solving it. And while you're at it, I would like to quickly thank the sponsor of this video, Babbel. I've done a lot of translating to try and read these exam questions and the comments, and I've actually been using Babbel to learn just the basics from the Turkish language to make it easier for me to pick out keywords. Babbel is a top language learning app that teaches real-world practical conversations through 10-minute interactive lessons, as well as podcasts, games, videos, and live classes. Babbel teaches more than just vocab words, and also teaches you about the language's culture, people, history, and traditions. Hoşça kal.
Hoşça kal.
İyi günler.
İyi günler.
Learning a new language is the perfect way to work on yourself in 2022, and Babbel is offering a 20-day money-back guarantee. You can get 65% off by going to my link, which is down in the description. Teşekkürler Babbel, and now let's take a look at the solution. So there might be a number of ways to solve it, but the simplest way I found was to try and find out how many TVs each degree of the pie represents. I'm going to define this variable x, which is how many TVs there are in each degree of the pie in 2019. And also I'm going to define y, which is the same thing but for the 2020 pie chart. Now let's look at the chart. We will want to know how many degrees are in this section K. At first glance it might look like it's a third, 120, like this one down here, but actually it's not. If this one here, L, is 90 degrees, M is 120, and in total this has to add to 360, then K will actually be 150 degrees. Over here it's a bit more simple. We've got 90, 90, and so this one would have to be 180. If we can find X, then the problem will be solved by finding 150 times X. That will be how many TVs this chunk represents. If that's 150X, then this one here is 90X, 120X. Since the number of M-brand televisions increases in number by 40, then this section here will be 120X plus 40. And since L decreases in number by 25, this one here will be 90X minus 25. But these segments can also be represented using Y. This one is also 90 degrees times Y, and this one down here is 180Y. And since these represent the same number of TVs in this chunk, we can write 90x minus 25 is equal to 90y. And for this one, 120x plus 40 is equal to 180y. This is our key to solving the problem. We've got two unknowns, but also two equations, so we can solve this for both x and y. Rearranging the top one for y and subbing that into the second one, I get x to be 3 over 2. Remember what we wanted to solve the problem was 150x, 3 over 2. Remember what we wanted to solve the problem was 150x, so 150 times 3 over 2, well that is 450 over 2, which is equal to 225, meaning that C is the correct answer. Now it took me a few goes to get there, but if you found this easily, then congratulations, you're as smart as a Turkish 13-year-old. I can't help but think that if you already are studying so hard for exams this early, that by the time you get to those tougher university entrance exams, you may have already burnt out. But it seems like even getting into some of the best high schools is a competitive process. This is a question from that notorious university entrance exam. This is from the 2021 AYT mathematics paper. Translated, it says that p of x is a fourth degree polynomial with real coefficients. And it gives the inequality that p of x is bigger than or equal to x. It gives us three values of p of x at x's 1, 2, and 3. And it asks us to find the value of p of x at x is equal to 4. Now on an axis of x and p of x, this line here represents where p of x is equal to x. Our function is called p of x, but it could just as easily have been called y, and you may recognize this as more commonly called the line y equals x. This inequality tells us that the value of our function will always exist above or at this line, so in this region here. In fact, we can plot some of the points. At x is equal to 1, p of x is also equal to 1, so that point is on the line. The same thing happens at x is equal to 3. In between, at x is equal to 2, the value of p of x is 4, so it will be somewhere up here. And since we know it's a fourth degree polynomial, or a quartic, we know it'll be a wibbly-wobbly shape, but because it can't pass down into this region down here, it must look something like this. And our question wants us to find the value when x is equal to 4, so when it's somewhere up here. Finding the value of this polynomial at any x value would be easy if only we had the equation of this line. But the equation of this line is slightly hard to find when we look at it from this perspective. Instead, let's take a look at our inequality. If we subtract x from both sides, we have that p of x minus x is bigger than or equal to 0. Subtracting x off this function makes it something that's easier to find an equation for because it will intersect the x-axis. Plotting p of x minus x, we get something that looks more like this. And you can see where I've got these points from. I just subtracted x from these values here. 1 minus 1 would give us a value of 0 there. 4 minus 2 gives the coordinate 2, 2. And 3 minus 3 gives the coordinate 3, 0. I know the x-intercepts of this quartic, so I can actually write its equation. I'd get k, which is some scale factor that we're yet to find, x minus 1 squared times x minus 3 squared. If you're slightly unfamiliar with quartics, you may wonder how I know that these are both squared. Well, I can tell what they call the multiplicity of these zeros by actually looking at the graph. Also called the order, the multiplicity is how many zeros are at the x-intercept. For example, if the multiplicity was 1, that would be if this bracket wasn't squared. It was just a single value of x. In that case, the x-intercept would be cut in a linear fashion. The intercept would look something like this, or like this. With a multiplicity of 2, that's when we would see an x squared. And the intercept would look like a quadratic, something like this or this. This is for a multiplicity of 2, but also 4, 6, 8, and in fact any even number. And a multiplicity of 3, or of 5, 7, 9, and any other odd number, we would see something that looks like this, where the intercept is in there. Fun fact is, the higher this number of multiplicity, the flatter this section will look. Our x-intercepts come down and turn around in that sort of quadratic function, so that's why we can say that that would be squared. If we're dealing with a quartic, that is a power of x to the 4, then the total multiplicities added together will equal 4. We do still want to find the value of k, and we can do that using these points here. If we used x equals 1, we'd end up with 1 minus 1 is 0, that would all be 0, and it wouldn't be useful for finding k. Same thing would happen if we used 3. That's probably why they've given us this one in between. If p of 2 minus 2 is equal to 2, we'd have k. 2 minus 1 is 1 squared. 2 minus 3 is minus 1 squared. That would all be 1, and k would just be equal to 2. So this would be our final equation for p of x minus x, and that's all we need to be able to find p of 4. Plugging in x is equal to 4, it works out to give us the answer of 22. Luckily, that's one of our options, and so we can say that B is the right answer. I know that in the real exam you get a lot less time than I've taken here, but I'm trying to explain things as I go, especially if this problem is an unfamiliar type for you. What makes the exam even harder is that this might be an unfamiliar question to almost everyone. It doesn't look like it appears in last year's exam, and so there's not really any warning to prepare for something like this. Interestingly, this exam made the news in Turkey this week after a decision from the Council of Higher Education to change the minimum passing score. Whilst entry to the top universities will remain very competitive, students could still be placed in a less competitive program after getting as little as one question correct. In Turkey, there are many higher education institutes, but they're not all of the same quality. Perhaps this decision could lead to more low-quality institutes offering degrees that don't help to reduce the country's unemployment. Or we'll see private universities now accepting anyone who's willing to pay the tuition fee. Thanks.
今天呢，我要来做一个重大的宣布。诚如标题所见呢，就是我要成为雅思 思考生了。接下来呢，为期3个月的时间，我会把我所有准备雅思的过程，从零到我考完，我会完完全全的像实境节目的把它完整的拍下来。那其实呢，从去年我去菲律宾游学之后啊，我在那边其实思考了很多我未来的事情，包含我除了 YouTube， 我到底还能做什么嘛？因为我其实是从大学的时期我就开始在做 YouTube 了，然后我其实一直以来呢都有一个在国外长期生根的小愿望，但因为我之前呢都是比较是属于那种短期打工或是游学的方式，顶多在国外待个2-3个月的那一种。但其实我心里呢一直很希望说，哦，我可以待个大概半年、1年，是真的能够在当地生活。所以我就在今年的5月下定决心呢，我要来准备雅思。当我做这个决定的时候，我真的觉得超级不可思议的，因为还记得去年我在游学的时候，我就是想要当一个没有压力、快乐学习的 ESL 学生，完全没有多益跟雅思成绩的需求，所以我只要每一次看到雅思的同学在每个礼拜5还要留下来模拟考，就觉得哇，他们真的好辛苦哦。那有一次呢，我就是有一个机会，就是跟雅思的同学一起有一个模拟考试考。我当时呢，连雅思在考什么都完全不知道，我就是完全的裸考。一开始就是考听力跟阅读嘛，然后结果我一看到题目的时候，我就很慌，因为雅思呢，它有很多都是填空题，然后它的程度根本就是跟我之前接触过的多益根本就是完全没有办法比。因为我觉得多益它除了全部是选择题，你不会还可以猜以外，其实它有时候是听到一些关键字，你就可以找出答案了。但雅思呢，它有很多那种高难度的单字，然后跟它很会考那种同义词，就是完全不一样的字，但是意思是一样的。你知道雅思考试全程3个小时，然后我那时候写到一半，大概不到2个小时，我就写不下去，我就直接交卷，我连口说都没有考，我就直接走人。我就是一个完全对于读书跟考试，在我人生中就是一件我放弃的事情。然后我自己也自认为说，我高3学测完之后，我就再也不会跟这件事情沾上边了。结果我今天完全的打脸自己，我要来做这个挑战。因为我从5月开始准备到现在嘛，然后我在 YouTube 看了很多那种雅思考生的一些分享，他们其实很多都是他们已经考完了，然后就分享说，哦，他是如何自修，从1个月内就考到了8分，怎么样读书，有什么考试的技巧，首战就7分。我当然觉得他们给的资讯都很受用，可是其实我自己也知道这件事情不可能发生在我身上，我完全没有办法靠我自己的能力1个月就考到7分、8分。因为我觉得很多分享人可能他们从小英文学习的底子就还不错了，然后再加上他们本来整理笔记啊，或者是读书的能力就蛮好了。那如果真的要用分数来追根究底我的英文程度的话，大概就是我10年前考学测的时候，英文是10几分，然后比较近一点的考试就是我从菲律宾游学回来之后，我今年初有去报一次多益，然后成绩是落在500分左右。那对于雅思呢，其实我算是一半的白纸吧，因为我今年5月有开始在接触雅思嘛，但是我其实现在都还没有完整知道我的成绩到底是怎么样，所以我今天好不好亲自下海来当实验品，我就代表一个初接触雅思的考生，然后来实际试过每一个读雅思的方法，就是我可能会试过补习班啊、家教啊、自学啊、线上课程啊、语言学校等等，我会用尽我各种的方式，然后来准备雅思。最后这个系列的最后一集，再跟大家分享每一种方式的优缺点跟我自己最真实的心得。那我现在小小的分享一下我从5月开始补习的补习班，我补的是这间李兹蚂蚁。我当时真的是爬了非常多的文，我觉得我好像已经很久没有那么认真为了一件事情爬文爬这么久了。最后呢，我精选了3间补习班，这3间呢我都有亲自去咨询，然后也有亲自去做他们的前测考试。我最后呢就选择去李兹蚂蚁。如果大家对于我如何选择补习班的所有的心路历程有兴趣的话呢，可以在下面留言跟我说，我之后呢也可以再拍一支影片跟大家分享。那其实当初呢，李兹蚂蚁就是我的第1顺位，因为我自己在爬。
Now, once you get used to this middle variable, you don't have to give a name for it. you can just think about it in your mind without actually writing it down. dy d of sine of 10t, I'll just do it again without introducing this middle variable explicitly. Think about it. I first of all differentiate the outside function, and I get cosine, but I don't change the thing that I'm plugging into it. It's still x that I'm plugging into it. X is 10t. So let's just write 10t and not worry about the name of that extra variable. If it confuses you, introduce the new variable and do it carefully and slowly like this. But quite quickly, I think you'll get to be able to keep that step in your mind. I'm not quite done yet. I haven't differentiated the inside function. The derivative of 10t is 10. So you get, again, the same result. A little shortcut that you'll get used to. Really and truly, once you have the chain rule, the world is yours to conquer. It's puts you in a very, very powerful position. Okay, well, let's see. What have I covered today? I've talked about product rule, quotient rule, composition. I should tell you something about higher derivatives as well. So let's do that. This is a simple story. Higher is a kind of a strange word. It just means differentiate over and over again. All right, so let's see. If we have a function u, or u of x, please allow me to just write it as briefly as u. Well, I can, this is a sort of notational thing. I can differentiate it. I get u prime. That's the derivative. That's a new function. Like if you started with the sine, that's going to be the cosine. A new function, so I can differentiate it again. And the notation for the differentiating it again is u prime prime. So u prime prime is just u prime differentiated again. For example, if u is the sine of x, so u prime is the cosine of x. Has Professor Jerrison talked about what the derivative of cosine is? What is it? Ha! Okay, so u prime prime is minus the sine of x. Let me go on. What do you suppose u prime prime means? I guess it's the derivative of u prime prime. It's called the third derivative. And u prime prime is called the second derivative. And it's u prime prime differentiated again. So to compute u prime prime prime in this example, what do? I differentiate that again. There's a constant term, minus 1, constant factor. That comes out. The derivative of sine is what? Okay, so the u prime prime is minus the cosine of x. Let's do it again. Now, after a while, you get tired of writing these things, and so maybe I'll use the notation u upper 4. That's the fourth derivative. That's u prime prime prime prime, or it's u prime prime prime differentiated again, fourth derivative. And what is that in this example? Okay, the cosine has derivative minus the sine, like you told me, and that minus sign cancels with that sign, and altogether I get plus the sine of x. That's pretty bizarre. When I differentiate the function sine of x 4 times, I get back to the sine of x again. That's the way it is. Now, this notation, prime, prime, prime, prime, and things like that, there are different ways of, there are different variants of that notation. Other notation, for example. As another notation, well, you've used the notation du dx before. U prime also could be denoted du dx. I think we've already here today used this way of rewriting du dx. I think when I was talking about ddt of uv and so on, I pulled that d divided by dt outside and put whatever function you're differentiating over to the right. So that's just a notational switch. It looks good. It looks like good algebra, doesn't it? As a further, but what it's doing is regarding this notation as an operator. It's something that you apply to a function to get a new function. I apply it to the sine function and I get the cosine function. I apply it to x squared and I get 2x. This thing here, that symbol, represents an operator which you apply to be applied to a function. And the operator says, take the function and differentiate it. So a further notation that people often use is they give a different name to that operator and they'll write capital D for it. So this is just using capital D for the symbol d dx. So in terms of that notation, let's see. Let's write down what higher derivatives look like. So let's see. That's what u prime is. How about u prime prime? Let's write that in terms of the d dx notation. Well, I'm supposed to differentiate u prime, right? So that's d dx applied to the function du dx. Differentiate the derivative. That's what I've done. Or I could write that as d dx applied to d dx applied to u, just pulling that u outside. So I'm doing d dx twice. I'm doing that operator twice. I could write that as d dx quantity squared applied to u. Differentiate twice and do it to the function u. Or I could write it as, now this is a strange one. I could also write, this I guess says like that. It's getting stranger and stranger, isn't it? This is definitely
文的时候，我其实查到了超多雅思该怎么样准备的文章。我觉得他们的官网写了非常非常多很实用、很实在的建议。我觉得就算是你今天没有要去补习，你光是看他们官网的文章，或者是他们老师妹的 IG 平时的分享，我觉得就可以受益良多了。那李芝麻以他的听说跟读写是2个分开来的，我最后想说，我先选听说好了，因为我觉得口说的部分比较需要老师亲自的指导。那他们其实听跟说呢，也是比较注重在说的部分。每个礼拜呢是上课3个小时的时间，然后我报的是实体课啦。然后虽然说是实体课，但是他们其实是有分台湾的老师在他们补习班里面上课，然后另外呢会有外师的口说是在线上上课。后来呢，我也很庆幸我有去补习，因为像我这种就是平时不怎么会规划，或者是比较不会读书的人，就真的很需要像补习班那样有系统、有规划的带你怎么样读。而且我觉得，如果今天是我自己自学的话，我真的是完全不知道从哪里开始，而且效率一定会很差，也会不知道自己的问题在哪里。所以我觉得去补习是可以快速的让你知道考试的技巧。像李芝麻姨他们自己在口说上面，他们也有自己一套的口说回答的技术。
是他，是我来了！哎，太惨了，赶快入教。
Hello everyone. Today here I've got a stack of physics books that I got out from the library, and they all deal with ideas relating to time or space and time travel. I thought it would be really interesting to see how these books go about describing and illustrating time travel, because time travel is something that usually belongs in fiction books or sci-fi and is treated in a very fanciful way. But these are non-fiction books, and some are written by quite serious scientists. So I thought it would be interesting to see how they unravel the same ideas and how time travel is treated by people who are dedicated to studying it. The first book in our lineup today is Geometry, Relativity and the Fourth Dimension by Rudy Rucker. Now, if you've been following my short videos about the fourth dimension, you'll have met some ideas from this book already, but tucked away in its chapters, there's a compelling discussion on time travel. This diagram here is to get us thinking in terms of space-time. It shows these flat slices of our world that are moving forward in time. In this particular example, there are two characters, a square and a triangle, living on a flat plane. This is what their world looks like at 12 o'clock. But 5 minutes later, at this slice, 12:05, the triangle has moved towards the square, maybe to say hello. And then 5 minutes later again, at 12:10, the triangle has moved away, meaning that in space-time, you could draw the triangle as a worm that snakes over here and then back again, whereas Mr. Square remains stationary the entire time, and their world line is just this straight line. This just shows two characters, but you could try to represent the entire world or universe using these world lines, and it would be a vast tangle of worms. You could represent every atom by one line, and because every atom in a person's body is replaced every 7 years or so, there wouldn't actually be a single thread that goes the whole length of a person's life. A living individual is a persistent pattern of world lines, rather than a particular collection of particles. Drawing world lines helps you think of space-time as a structure all of its own, where the universe at any instant is a 3D cross-section. But that does make us wonder why we can't see the past or future if they really exist. One idea is that maybe all instants of time do exist, but because our memories only relate to events that happened at previous time steps to our present moment, we get the illusion that we are moving forwards in time always. The author then makes a slight departure from physics, but this next diagram helped me to understand meditation better than any yoga class I've been to. He asks if there is a way to be conscious in a static space-time instead of always moving forwards. Well, one trick to achieve the feeling of timelessness is to stop thinking new thoughts, because without that, it's hard to distinguish one moment from the next. To achieve this timelessness, you could either think nothing at all, which is not easy, or concentrate your attention on a repetitive thought loop, like a mantra. Thinking nothing, you can't differentiate one instant from the next, and doing a mantra, you can't differentiate one repetition of the mantra from the next. This next diagram here shows a way to time travel to the past.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru, au piano. Bravo et merci.
YouTube Music 是个音乐应用程式，让你选择最符合心境的歌曲，陪你战胜那些累人的深蹲。每天都是练腿日，试试 YouTube Music Premium。
Although it only works in a universe where time is circular. In this universe, the time dimension is wrapped into a cylinder and space extends infinitely out to the sides. This circle here represents the world line of the Earth. If you say that it takes 1 trillion years for time to repeat itself, so that is the circumference of this world line, to time travel we could leave the Earth, speeding off to the side for say 250 billion years. Then we could turn around and travel back this way for say 500 billion years. Then turn around again and take another 250 billion years to get back to where we started. But because time is circular, we will intersect the world line of the Earth in its past. Ideas of circular time have been proposed in physics, but there are plenty of practical reasons why a journey like this, taking 1 trillion years and needing to travel close to the speed of light, is not going to work. You'd need a rocket the size of a galaxy to have enough fuel, and you'd probably get lost. This next book is Paul Davies' About Time. In a chapter on time reversal, there is a discussion about antimatter and how there are things called positrons which are like anti-electrons. They have the opposite charge. But maybe they also go back in time. Electrons and positrons are created together in pairs. Usually it's from a photon colliding with an atom. They fly off and hope to never see
You have already lost.
想要零广告、下载音乐并离线播放及背景播放吗？试试 YouTube Music Premium。
Demacia is counting on us. I never hold back.
Always on the run.
'Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru au piano. Bravo et merci.
YouTube Premium 结合零广告 YouTube 与 YouTube Music 应用程式，一个订阅双享2个应用程式，免费试用1个月。
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru, au piano. Bravo et merci.
订阅 Music Premium， 从此零广告，儿歌也可以不受干扰循环播放了。试试 YouTube Music Premium。
together in pairs. Usually it's from a photon colliding with an atom. They fly off and hope to never see each other again, because if a positron were to run into an electron, then the pair would instantly annihilate and reverse this pair creation process, giving back photons. This is a space-time diagram, where here a photon coming into point A creates an electron-positron pair. The positron then meets with another electron and annihilates, giving back a photon. At this time t, an observer would see three particles, an electron, a positron, and another electron. But according to Richard Feynman, this zigzag track could be viewed as the world line of just one particle, an electron that travels back in time between these annihilation and creation events. That's why the arrow here for the positron is pointing backwards. Feynman's theory was that this is all just one electron, and it travels back in time for that brief period where it is considered a positron. This idea could be extended to include many more electrons and positrons, and you could say that all the electrons in the universe are just the same one particle, that there's just one electron making up the entire universe. It offers a nice explanation for why all electrons appear to be identical, but that theory comes with problems of its own. It would also predict that the universe is made exactly of half matter and half antimatter, but we don't see nearly as much antimatter as we do normal matter, and the arrow of time in our universe appears to point forwards, rather than having a symmetry pointing backwards. Another way to time travel to the past is detailed in this next book, Time Travel in Einstein's Universe by J. Richard Gott. Gott mentioned something called cosmic strings, which are thin strands of high-density material left over from the early universe. This diagram is designed to show what space-time looks like around a cosmic string. It's like a piece of pizza missing a slice. If we take out that slice and stick it together, we get a cone. Here, my pencil is the cosmic string, and the cone is what a horizontal plane of space-time around the string looks like. Suppose that here's the Earth, here's the cosmic string, and here's a quasar, split across the region of the missing slice. These straight lines show the path that light would take from the quasar to reach Earth. And here's what those paths look like in the conical space-time. To us on Earth, it will appear as if there are two different quasars, even though it's the same object. And even though the light is traveling on the shortest, straightest path to us from the quasar, one of the paths will be shorter. This is the principle of gravitational lensing, and may be what helps us to find cosmic strings. The light traveling along path 2 has beaten the light traveling along path 1, and if it was a rocket traveling along path 2, traveling at nearly the speed of light, it could have also beaten light path 1. If cosmic strings exist, then you could travel in a spaceship and outrun a light beam by taking the shorter of two paths around a cosmic string. When the rocket arrives at Earth, the light showing its departure from the quasar won't have arrived yet. So you could look back and see yourself still on the quasar, about to depart. On another page in this book, there's instructions on how to build a time machine that can visit the future. To construct this time machine, you need to find the mass of the planet Jupiter and construct it around yourself into a spherical shell. That will create a huge gravitational well around you, but because it's a sphere, it will perfectly cancel out in every direction, and inside the shell, you will feel unaffected. We're just teetering on the limit of mass concentration that would create a black hole, so you don't want to go overboard with this. Just outside of the spherical shell, you would be torn apart by tidal forces generated by its gravitational attraction. But inside the sphere, you would be perfectly safe. This diagram simplifies the situation down to just a two-dimensional shell. So it's drawn around this time traveler here as a circle, but for us it would actually be a sphere. If you imagine an ant falling into something this shape, it would require a lot of energy to crawl back out. The same thing will happen with our photons. Photons emitted by us will lose a lot of energy on the way out and be redshifted, turning into longer wavelength light. Photons from outside of the well that fall in will pick up energy as they fall. The person inside of the well would see these waves oscillating faster than they did on the outside. And if the people outside the well had been using a clock which relied on the oscillation of these waves, the person inside of the well would see these clocks to be ticking 4 times faster. If the time traveler managed to safely disassemble the well, he would step out of his time machine and be younger than those around him. Another way to time travel to the future is by moving really fast, usually running away on a rocket going near the speed of light, leaving Earth for a bit, then turning around and coming back and being younger than everyone around you. I think this diagram does a good job of explaining why a clock on a rocket ship moving fast actually ticks more slowly than one that's left on Earth. If you construct a clock that uses the bouncing of light off mirrors to measure the time, then this is what our clock on Earth would look like. The light would predictably bounce between the 2 mirrors, and the clock would tick every time it hit one. Give that same clock to an astronaut on a moving rocket, and if we observed that astronaut from the outside of their space station, this is what we would see. The mirrors are still separated by the same distance, but because the rocket is moving past us, we will see the light bounce off the bottom mirror and then bounce off the top mirror, but the distance between the mirrors will no longer be the initial 3 feet separation. It will be longer because it's traveled on this diagonal line. Because light travels at a constant speed, if it's traveling a greater distance, then there will be a greater time delay between these 2 ticks of the clock. So this astronaut's clock will tick more slowly compared to ours. It will happen to everything on board. Even the astronaut's heart is a kind of clock. And that is why when the astronaut returns to Earth after their journey, they won't have physically aged as much as someone who was left on Earth. Most books that mention time travel will have one of these, a Minkowski or space-time diagram. These diagonal lines represent an object moving at the speed of light. Anything less steep than that will be inside of these cones and will be from either the past or the future of point P. Because things can travel from anywhere in this region to P, anything in this cone could have affected P. It is its past light cone. Same with the future. Anything from P could affect anything in this region. But these points A and B are outside of the light cones. This is the region of elsewhere. Whilst A and B might happen at the same time as P, they cannot affect P because light could not travel from here to here. All observers agree on the light paths because light travels at the same speed for all observers, but depending on how fast you are moving yourself, the axes X and T will actually move and change based on your reference frame. And now here are some highly commended extra entries. Space-time breaking up, where at a mini microscopic level, quantum effects are so violent that they start to tear space and time apart completely, creating a sponge-like structure of wormholes and bridges. This activity would be unnoticed by even a subatomic particle, which would be larger than the wormhole. This one shows a rocket stuck inside of a black hole. The rocket is always dragged back down, and so are light signals that they try to send out. There's no escape and no way to let anyone know that you are here. This figure shows black and white holes. A is a collapse to a black hole, and B is an explosion from a white hole. This one's too complicated for me to understand enough to explain, but the study of black and white holes looks very cool. Here's an interesting model called a self-creating universe, where the universe has a time loop at its beginning, meaning the question of what happened before the universe existed doesn't really apply, because according to this, the universe is its own creation. And if you were to go back in time throughout the history of the universe, you would end up intersecting with your own tail. Thanks for joining me on this look through some physics books. Thanks to my patrons for making this video possible, and a special shout out to today's patron cat of the day, Freeway.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru au piano. Bravo et merci.
YouTube Music 可以使用 Google 助理来播放歌曲，试试 YouTube Music Premium。
Thank you.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru au piano. Bravo et merci.
YouTube Premium 结合零广告 YouTube 与 YouTube Music 应用程式，给你不间断的影片与专属音乐的应用程式。YouTube Premium 一个订阅，双享2个应用程式，免费试用1个月。
mesdemoiselles, Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale, et Béatrice Berruy au piano. Bravo et merci.
想要零广告、下载音乐并离线播放及背景播放吗？试试 YouTube Music Premium。
有可能大他的空间。
是有操作，
对。
但你能想到现在是 BDS 领先2000块吗？右边这个打节奏阵就没打出来，
这边主动跑线咯，这也是 Aiden 他自己讲说他自己最爱玩的一个玩法。
他直接主动跑线，
他自己是会主动去跑线，
而且下路有5夹的位置。
Never forget Ionia. Stand ready. They'll be fine. The void has breached this place. Submit. You have already lost.
My Runeterra will be beautiful.
Fear the void sting.
Always on the run.
I've got them. I never hold back.
I may be merciful, but Targon isn't.
world is frayed and in need of mending.
I may be merciful, but Targon isn't.
They'll be fine.
My Runeterra will be beautiful.
Where there is evil, I shall go.
味道来拆塔了，拆除队，
哇，这个人
一件一件的，
哇，这么原来要把优势辐射给下路是这么简单的事情吗？
直接走过来，塔给我，A 的大喊塔交出来，
对，他会退我们就点，
对，一切都是如此的简单。
讲的那么复杂，辐射下路怎么辐射？选盖伦带点蓝，
没错
就这样，
打线优势后直接来抓人，要抓卢勒了，
去
布里坏者走位，用走位躲掉，再飞一个大，这里能拉扯。
我这里盖伦在下半波的话，上半波他们的进攻能力就比较强哦。
是，
目前还是依靠盖伦在团战里面的伤害的。
预示着京东赶紧吃，这波节奏并没有断掉哦。
现在路勒过得是很不舒服的哦。
现在发育很好就是。
现在可能要直接转到中路来了。 因为毕竟现在的下路塔有点带不了了，只能靠中路来防守，然后看能不能依靠369从河道过来的一些比较好的角度开大，直接把团战打起来。
是哇，但现在野区的压力是真的有点大，盖伦消失了。
现在遇到飞爱头锁住 ，Aden 冲过来，那个人头就一定是掉下来了。
是。但中线有个眼，京东这个视野布置的很到位。
现在 Nuke 是很舒服的在发育的、越拖后面，其实 BDS 的阵容未必是比较弱的、
是。还是有很多碰撞的可能性的。小龙先开京东，人员已经踩好位置，视野部署不错，但后面有一个眼睛。而且后排还有一堆眼睛是 BDS 策划，而京东竟然没有排空的，
直接 TP 到线上了。
进来做后面的包抄，身边有个 Aden 在走位，京东抓到人，准备要 all in 直接秒掉，没有问题 ，Aden 直接倒地。京东这波的激活非常的漂亮，
而且嘉文还有大绝的哦，嘉文是还有大绝，还能进攻的。
这一波正面想进来，盖伦扛不住，小龙京东稳稳拿下。这还是京东哦，
打团还是很强的，打团还是很强的，
稳定下来一波康博将人击杀，但现在需要想追，直接是锁了一个牛，
亚历斯塔
牛开大，满血要走，
加瑞空，
看起来是看到对面阿里 TP 上去，所以这波是个。
Demacia, now and forever.
Bravo mesdemoiselles, Camille Thomas nommée cette année dans la catégorie Révélation soliste instrumentale et Béatrice Berru au piano. Bravo et merci.
Music 音乐应用程式，为你打造适用任何活动或情境的专属合集。无论是运动或想大吃整桶冰淇淋的夜晚，试试 YouTube Music Premium。
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru, au piano. Bravo et merci.
想听你最爱的歌手有哪些你还没听过的歌曲吗？试试 YouTube Music Premium。
杀一下，但无伤大雅。
对，这个大绝就交的有一点随便，因为毕竟自己的差雅其实是回头了啦。
没错，
如果你要交大，你加一个瑞空，现在的卡萨比亚伤害也是不太够的。
没错，两边的辅助打情骂俏，在右边开始碰撞了起来，同时连卡纳比也是赶了过来，看起来有机会杀哦。
现在369只要下去推线，其实 BDS 这里还是可以再主动一点做进攻的，因为毕竟他们现在被开到他们最不想看到的画面就是在河道或者在侧边被369的羊直接撞到。
是，再来看一下 A 等全部都走在眼上，而且牛好像是在草丛外海克斯闪现，
已经完全知道你要从这里过来，而且你的蛇女是 TP 下路兵线的。
没错，
大家知道你的大部队这个时间点一定在下半部。
这一波盖伦死的速度非常快啊，所以等级也开始落后于369喽。A 等369慢慢的发育，已经状态拉起来了。另外一边的话 ，A 等的打法还是跟队友集结的方式，那这样等级啊 CS 这样慢慢被拉开了。
现在如果要提速的话，就是要去进攻中路的外塔了。
没错，
中外塔进攻下来，接下来蛇女的发育更舒服。等到她的强势期到，其实京东这边相对是难发挥的。
是，但京东这个发育，尤其是中路吧，奈德这把201哦。
刚刚的团战里面还是都有拿到人头的。
是，
那接下来就可以果断一点，直接提速了。
BDS 倒是现在比较尴尬，虽然是领先的，但盖伦这角色没带 TP 啊，这时候
不过盖伦只要每一波接线 ，BDS 一定要去找2的位置，因为他们的阵容其实很怕被2直接做强开的。
是，现在京东人确实正在找寻开战的时间。
可以看到369其实推完线就是一直往中路靠，就在等你有一波走位失误，我就直接开战。
只要有抓到一波团战打完，以现在的时间有机会直接吃8龙，所以对于京东来说就可以阻止盖伦的分推了。这一个团战一波团是很重要的，
而且他们现在中期的进攻箭头已经成型了，就是阿里这里，阿里跟就是奈特跟卡纳比的进攻箭头。
是，草丛不会有人吧？奈特没怎么在想，但菲亚来了，有人来了，布里坏的再转，奈特交闪，但大绝炸下去，身上有点难烫得死吗？就是一个闪现重击秀，直接把奈特给重死。
可是对方有预示者啊，那这样你中路1、2塔都守不住了。
但对面趁着这波就集结，
不过盖伦是有爆破的啦，
是想换上下路的2塔，就是，但中路是连续2波直接掉光。这波杀了奈特，花费了大量的资源。
但是这里 Eden 推的也很快，
但对面想回包，这里回包有机会杀 Eden 哦。但 Eden 推完好像要溜了。
要回包应该比较难，因为毕竟阿里是还没有复活的，
而且室友还直接肉身挺进去，看到2个人就是照扁不误。对面觉得很怪，你怎么敢这么大胆？张勇 EQ 大招后面撸了赶了过来，伊卡西亚魔芋顺势狙击，将人都给拿下，不得已狂尼也只能交闪拉开，拉布罗也是可以跳走。这波最后死的竟然是冲进去的室友。非常冲动哦！
只要你的 Eden 不在的话，其实京东这边都还是很愿意跟你做碰撞的。
是，因
为你大部分的经济还是投资在 Eden 身上的。
刚刚我觉得京东也觉得很奇怪啊，觉得这个菲爱怎么这么凶？
他怎么敢顶上来啊？
是，他在场里面打一阵子。
不过这里的话，就是 BDS 的想法是好的啦，就是他们想要在这里抓边，但是一定要直接秒杀。因为没有秒杀的话，京东这里有预示者，对方放预示者，你抓边是很有风险的事情。
没错，这里很凶，需要冲进去，给你2拳啊！干嘛在我家？大哥，抱歉，大哥。
对他现在完全知道盖伦就在下半部，你们的战斗能力其实没有那么好的。
是，这里狂你是闪现大绝全交了，这时间的差雅的状态已经是不太够了。
对，而且现在你的中路1、2塔都陷落的关系哦，所以其实你现在视野也没有到那么好做了。
没错，
反而是你有可能会因为这个视野的劣势，让阿里有更多抓边的机会。
解法是盖伦偷偷摸摸，
盖伦的位置很好哦，
他看起来
锁定撸了，
正在看，已经锁定了其中一位选手是谁呢？他还在等，
对，还在，就是看他，就是看他，
就看他撸了，走进去，
逮到你了，
你好，但对面有进化，可以直接走。
哇，这边撸了交大绝喽，
而且 Aden 也得交闪，
对，但 Aden 还有大，他还有大的，
是，哇，这波撸的反应很快，他知道他草丛呀，这里，哇，后面滑行啊。
直接把 Eden 直接关在里面。
来看一下这里，
对，这里因为你原本的视野优先权丢掉了， 所以你不得不来探这个视野，可是你又跟拉波鲁分开了。
是，
对，这里就是比较不小心哦。
最后 BDS 这波团战的落败还是在于细节上面的把控哦。
其实这里369这个大绝第一段、第二段配合卡纳比的大绝基本上是同时的，真的是非常的协作性非常的高的一支队伍。
哇，后面
这里的话就真的没有什么办法了，毕竟是没有前排了，
非常绝望，盖伦没有操作空间。哇，后面滑行啊，卡纳比滑了进来，
伴随着一个惨叫声，
是准备要来送走 BDS。整体的经济逆转，而且有巴龙推进，同时凯撒3件套了。除了这一把，
这其实也有很多队伍，就是有很多的主播赛评有在提到，就是 BDS 这支队伍其实他们的中下双 C 不是那么有能力接管比赛，就算他们前面拿到的优势，其实他们也没有太多接管比赛的能力，反而都还是靠 Adam 去做那种比较硬要的尝试。
像现在的分推吗？
对，这就是最硬要的那种，就我完全就不管了。
开推，哎，这里要先
反正你 EV 应该是打不赢我，那我就直接分推。
是，但你分推的话，失去的不只是下路了。
因为 Crony 这把其实也并没有到真的被 gank 到还是怎么样，就是他反而是自己在团战里的发挥就是没有其他的 AD 好。
没错，刚刚几次的碰撞其实也没有办法差雅能够逃脱，没办法使用差雅去做一些操作。哇，那最后这资源全放，
那这样要想办法打起来喽，放的东西有点多了。
选择往前要抓，想 EQ 走的卡纳比被留住，但他还能扛。选择浩劫降临反盖后引起战争拖时间，但还是被秒了。后方位置 ，Crony 一直在点坦克，但点不动2。右边进场蛇女已经倒下，凯撒在往前的飞行抓掉了想逃跑的盖伦，撸了拿下人头，奈特也拿下一个 triple。
刚刚你想抓我，这波我抓你，
一波反抓，再打出了一波1换4，团战打完了。BDS 前面的战术在面对京东的策划，最终没有打出太好的效果。京东2波团战送走 BDS。在送走之前，还要先再送一下虚弱走，没有成功没关系，拿下主堡，拿下比赛，也拿下京东的第1场比赛胜利。
那个巴龙的探视野上面，旭友还是太年轻了，真的还是给了这种1级强队一个很好的机会哦。
最后打的都是细节上面
啊，感觉只有京东可以掰掰手腕。
是，但毕竟其他的 LPL 战队还没出场嘛，就李宁啊，然后微博等等的战队还在接下来。
看他们季后赛觉得不怎么样。
哎呦。
说实话，就感觉不怎么样。
没事，但这是季后赛嘛，来到世界赛，说不定他们又在这中间又练了不同的东西出来，版本也不太一样。
好像也是，
就还可以再期待一下他们在后续比赛出来的发挥。
是，
但不过以 DK 真的要提到他们在可能这个夏季的状况嘛，其实在辅助位上的变动是比较大的。一度曾经换到一个 Bible 选手上来顶了一段时间，后来发现好像还是 Killing 好用一些。
有时候就是要换个人才知道队伍到底哪里有问题。
但换了换，发现好像也不是什么太大的问题，好像本来的那个比较没有问题。
就你不换你不知道啊，你不换你会觉得是他有问题啊。
经典那句话吗？失去了才懂得珍惜。
哎，没错。
哎呀，
你换了之后，你才发现原来不是他的问题。
是，哎呀，这只能说 DK 确实在换完了辅助之后，就整体在季后的状况，就越接近季末，他们的状况是越调整越好了。不然其实这一季其实很多的对于 DK 的讨论啊，不管是这个中野是不是没有以前这么强了，或者说 Kena 是不是真的那么不稳定等等的一些说法，
是。
其实，在 DK 身上这一季是过得比较坎坷一些，但最终他们还是站在这里了。面对到的是对方来自欧洲的这个无敌大魔王哦。
看一下，还行哎，我说实话，这样玩的话，G2有点赢不了。
哦，你说还到目前为止还没有明显的优势出现，差不多了。
这个茂凯放弃了一堆野怪在 cover 下路，就下路的优势也没有想象中的大，说实话，
就顶多10支以内的 CS 领先。
对，
看起来确实以想象中起来，到了6分半。没有，就是那种真的会让 DK 的下路那种痛苦面具戴起来的感觉。
对，
但中路突然一波滑上来，逼出了 Caps 的闪现。
横转，这就是经典阿奇尔。
是大绝换闪，
就是6分半的时候来中路逼一波闪，后面5分钟内对面中路都要在塔下挂机，会影响到连带的上下路线的对线。这个很经典啊，这个就是玩阿奇尔必备的。
是，但 Caps 现在好像想要来挽回一下颜面，他觉得他不能没优势，但这上去换好像也没换出个什么所以然。哇，那这样子中路也确实是失去了线权，失去了推荐的主动权之后，这上下路就上路已经本来看起来就过得不是很好受了，下路本来就赢得不够多，现在看起来赢得更多是有点难，而且这波也看得出来，这血轮也是真的有料，
真的有料。
对，突然就连插你3下，而且是 Canyon 过来
跟
亚哥打了个招呼，
想要吃河蟹 Q 重击带走。
哎呦，最后是哇，最后是茂凯的 Q， 但是瑞尔的重击。
那我只能说他的重击用的真好哎，
猜到了过程，但没猜到细节，
怎么中输啦？
哇，
好像他也按得中哎，但是好像 Q 没打到哎，目前看起来是这样。
你说 Q 打到一半之后，这个2个重击先下了，2
个重击一起下了，那也没办法，我只能说
很可惜，
我只能说运气不好。
对，野王还是野王嘛，毕竟以艾克来说，他算是今年算是新秀啦，就 G2 从这个 EU Master 挖上来的一个新人。那在他对面的当然就是这个吧，前世界冠军 LCK 的这个野王 Canyon 北极熊。
就套一句我常讲的嘛，这把 Ken 用来了也没救，
但这把是 Ken 用亲自上去打，他从头打到尾。
对，所以我的意思是说，就是我 Solo Q 打起来是有机会输的啊，对面也没有第三，捅不动这个大树，好肉啊，这就是水龙魂吗？
哇，这回天的速度，再加上这个伤害的补上，熊妹克看起来很尽力在戳了，但就是戳不死。
没办法，他还没有那个吧穿透。
对，
有了，这波有了。
那这波插来伤害就有料了。但一样的问题，就对面还是有水龙魂，对面还是会不太害怕你的 poke 能力。
那个大树很聪明哎，他给我买那个
脏手。
哇，
那个咒恨符锁出起来了，
直接绑熊美可哎，难怪刚插他那么痒，
说不定刚刚已经有穿透，但就是这个咒恨符锁起效用了，
刚刚已经有那个脏手了，
对他刚就有了，只是不确定刚刚熊美可有没有穿透。
哇，好有想法啊，这个人。
对，哇，那这波下来真的不好说了 ，G2 真的把这个状况翻转到目前的位置，一个前中期加速阵在34分钟看起来居然还有优势。
因为他拿到，因为我前面有讲，他的胜利方程式是要拿到龙魂啊。
对，
就他拿到这个龙魂，他的胜利方程式就……
这边水蓝跳盆闪绑 Kenna， 但 Kenna 也是按了闪现回到一个还算安全的位置，反而是 Hansama 这边喷掉的血比较多了一点。
怎么能不死啊？不是啊，这闪绑拍回来接一个空接囚女技能，怎么可能不死啊？
但看起来就是有人扣招，或是有人的技能衔接出了点问题。右边是 Broken Blade，
感觉
在单打一套，反而是被 Kenna 给追着扁，直接锤上去了。那 GA 都被打了出来 ，G2 有人要救一下吗？再一次同样的位置，大鳄鱼又再次站了起来之后，两端的大切八块又回到了河道。Kenna 开了一个比较奇怪的大绝，没有把这个鳄鱼给吸了回来。G2 这次继续转回中路，继续他们的攻势。
这个也没死，我都感觉他死定了。
两边上路都大难不死。
哇，这就是水龙魂嘛，而且是3条水龙的水龙魂。
哦呦，那不得了！下一条巴龙的重生 DK， 现在要怎么探？怎么 poke 对面？才刚打完的血量，又耗着水龙魂给回起来了。
右边少了，
上路线，这是来自熊美可的绕背 TP， 不过正面的恶意收购已经开启 ，Deft 也知道了，巴龙已经被亚哥给重击下来。那 DK 后续的追击，
熊美可的位置
被插了2下，其实伤害还算不错，但只能弹一个球果离开。
这个 TP 绕背很有料哎，这个
G2现在是想走走不得，想开不到。再往前插了一下，又捆到了 Miki， 打成半血。不过这时候是亚哥回头的鬼灵之后来掩护的是 G2 私下队员的撤退。在三角草丛，没有人舍得按这个 B。
不行，这个 B 一定要一起 B。但凡有个人留下来，你有没有看过那个鬼故事？
哎呦，
那落单的
必死。但现在确实5个人抱团，没有人死。哇，这看起来不是恐怖故事，
那就是远古龙魂啦，看重击啦。这边就是打野的比拼了。
这是30秒。
这边可能要请我们那个34岁的人。
哎呀，你说这个重击中下 MVP 的男人，
没错，
好像就在韩国，
请他上来中一下。
我只能说，谁请到这个神，谁就能拿下这把比赛。
是的，
现在是请神环节了，36分钟，这没想到局面居然会到目前的这个远古龙魂团。G2 探的方式还是比较小心，一炮打到了后排身上，但这个河道都还是 DK 先踩好了位置 ，G2 只能从下半区慢慢的往上看。但由于有水龙魂的关系，其实前排吃 poke 是没什么太大的问题。下路线，Hansama 也往前推，现在是 DK 的压力比较大了，
吃得了 poke。
对，但现在是没有人可以敢往前做第一拍的开团。
是的
，Kenna 的位置也在对方的红区，而且是没有被掌握到位置，但是后面有一个绕背的 TP。
有被发现吗？
好像没有。Canyon 撤退的位置是往中路线上撤退，但是另外一边草丛要冲出一只君临天下的大鳄鱼，先咬住了 Canyon， 不过 Canyon 交闪往上墙，有赎罪神石再回了一口血，
左右开炮。
下面的 Canyon 还在打 poke， 但现在看得出来上路杰西，下路法路士的 poke 已经打不出太大的效果了。
我感觉要去比地耶，这个杰西要去推中呢。
有了，照你所说的去推了中线，但是推了中线 G2 看到了这个点位 ，Miki 绑住了 Killing， 打了一整套的血，坚定一只还扣在手中没有打开，但牛已经没有了状态。
不知道我们杰西为什么不赶快去带线啊？他在干嘛？
有点怕，但是这个窄口再一次的恶意收购，收购到了一个 Canyon。那现在 G2 回头开始动了远古龙，
他好像他在干嘛啊？他在散步哦。
哎，前面的多连锁也空了，那现在法洛斯也空大，这个窄口 G2 是完全守住，不让 DK 任何一个成员有办法往下踩。下面有一个 Kelly 的绕背，但这个位置则是被对方的 Broken Blade 给找到，开了坚定一次，还是被收下来了。
完了，
霸道手腕往前一个，这波的回转死神刮到2人，远古龙魂将要由 G2 确保下来。
我真的觉得他不带中线，真的不知道在干嘛。他一定要带这个中线呢，因为不管说这波远古龙魂掉了还是怎样，这个中线影响都很大。因为他把中线推了，如果这个远古龙魂掉了，对面也没兵线来压高地啊。他如果说他不推这个中线，你看现在要被压高地，对面想一波了。
但 Kena 很急啊。
不是啊，他在那边逛街，他也不能上去 poke。那他刚在那边逛了10几秒，不知道在干嘛。
对，他从对方的红区一路逛回自己的蓝区，绕了一大圈，现在反而是 G2 反踩了对面的中路兵营。
这样感觉没救了 DK。
哇，那这把比赛没想到转到了这边，还是 G2 掌握了优势。
这样打感觉要输一输。
哇，那这样子远古龙还要再撑1分半的时间点。
1分半嘛。感觉茂凯有闪绑就随便闪上去，随便绑，随便开，
绑个前排也行。
只要能把团开起来，就不太可能输。
对，但看一下装备的话 ，Deft 有的是 GA， 中路的 Showmaker 有惊人，这个双 C 比较容易被开到的就只剩上路的 Kena 了。
回一波吧，这里钱应该很多吧？我觉得下一波直接来中路来个大决战，
定生死，就用这个远古龙
之战。
哎呀，用这个远古龙最后的 buff 时间
就对看啊！这个茂凯只要找一波闪绑接个穷女大，基本上就直接虐烂。
而且以 G2 能够去进攻的点位，上半部的 DK 野区是没有太多的视野的。
是的，或是不急的话就是带下路线，不想中路这样子，那就带上下路线，找机会再慢慢把优势扩大。
不管怎么说，远古龙在他们手里主动
这时间点 DK 是不能接的，敢接就是想输。
是，但真的要拖到这个远古龙没有的话，他们的整体在高地外的视野都要放弃。就算是要接这个1分半之后的巴龙来说，也不好后一踩。
G2 选择一个是最稳健的打法啦，没有要利用这个远古龙跟你决战啊。
哎呦，对不对？
哇，好
烧，
不会吧？
吃到一个树精就有点挺不太住嘞。
这什么？
这就是亚一个的茂凯。
哇，这什么东西？原子弹哦，
这不玩纯工具人的，这出完2件这个防御装之后，马上紧接着大面具，这个
好猛，
恶魔之勇，接着是他的这个暗影之眼说出来，再配合他的先发制人，这烧的伤害特别的高。选择推上路，远古龙最后的10秒钟，
只能给，
要为他们带来的是上路的兵营。那现在是中上双兵营
，G2 打了一个最稳健的方式。拿双兵营，利用这远古龙然后再来拿巴龙，等一下就是3兵营 How to lose 啊。
是，对于50秒钟，这是 How to lose 的环节。那对于 DK， 在这个迈向 How to lose 的最后一步之前，有没有办法阻挡 G2？
3兵营火龙魂输的我是看过了，但是水龙魂的输的我是没看过了，所以应该是不太可能啊。
是，
主要还是右边这个 poke 阵，它中期巨大优势。但是打到这里，对面水龙魂他的那个 poke 阵直接裂开，
没有优势了。
对我只能说运气真好啊，
运气真好，真的。
G2 运气真好。
要是这个 G2 这把是个风龙魂，但
凡是其他龙魂，我觉得都还好，
就是可能是个什么电龙，
就都还能打，
对，都还行。
反而是水龙魂，就 poke 阵最怕就水龙魂了。
但现在是 Canyon 的一波开团捅的球果，把 Mickey 往外一捅，但现在反而是 Canyon 自己的位置有点差，在窄口这波又是完美的恶意收购到了3个人，但是现在 DK 前排的状态其实还算可以坚定，一直顶了非常久的时间，但是一刀的回转飞斧追着砍，顶了回去，他只能把自己给卖掉。但是又一波闪绑到了 Kena 是没有任何能够保住自己性命的技能。下面的 Showmaker 也是绝望的一推 ，DK 瞬间倒下的是3名成员 ，G2 直接 TP 掉了对方的高地，准备要来结束比赛的这个41分钟的时间点。要把 DK 给逼入绝境 ，Deft 闪现出了高地，被这只鳄鱼给吓跑，但现在想要回手，对方直接不理他了，眼中只有珠宝，现在钻回了他的身旁，打出了他的 GA，5个人站在他身边，恭喜你，世界冠军，想要卫冕，你跨不过的是 G2 这一关，
很强，果然是 G2。
我们准备恭喜 G2 结束了这把峰回路转的比赛，在42分钟拿下他们的第1胜。
love democracy. It's the only place I know.
Music Premium 让你尽情聆听，即使关闭荧幕或使用其他应用程式也不受干扰，让你听音乐就像试试 YouTube Music Premium。
And in need of mending. Sharima will live on without you. Here I come!
Now and forever.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru au piano. Bravo et merci.
YouTube Premium 结合零广告 YouTube 与 YouTube Music 应用程式，一个订阅双享2个应用程式，免费试用1个月。
you just play for that, and every skirmish should be like.
As we see it in front of us. So let's see. Let's head over to our casters.
Of course it will be, guys. Thank you very much, as always. Introducing what should be a favourite matchup to the audience. I'm Asterix. This is Vedius, by the way, to take you into this next one. Now,
be honest. Be honest. How excited are you to cast Weibo?
Very. There's no chance I wasn't going to come into this and talk up the Shy. However, what I've just seen is the first seed from LEC take down the 4th seed from the LCK.
Yep.
So by that logic, that means the first seed from NA can take down the 4th seed of LPL.
I mean, I think champion on the current meta, but do they want to prioritize that AD carry? No, instead it will be Alistar. 3 games in a row now we've seen that Alistar be super prioritized, typically from the LCK teams, but Ignar saying, nope, I want engaged support. I always associate him with Rakan, but maybe into the Poppy, he's not as excited about that prospect.
Maybe not. I mean, today, again, it's just been coming out left, right, and center as the priority pick. NRG options in the bottom side. Didn't see Kai'Sa last game, but we're going to miss it for a little bit longer as the potential flex here for the Taliyah gets locked in for NRG.
Definitely a potential flex. Glad you brought that up because Palafox, no stranger to the Taliyah in the mid lane. More than happy to play that. And so both sides holding their cards close to their chest. But will it be the Rumble for the Shy?
Oh, I bet you it will be. This guy's been playing it non-stop. I mean, Weibo, again, with such a volatile top laner, he just goes, you know what? I'm going to pick Rumble blind.
He's going to blind it.
Instead of the Cassante.
I mean, he's testing Dokla here. He's saying, what have you got? You know, he is so confident in his Rumble. Look at the damage that Weibo have for themselves right now. Potential poke, depending on the build that Kai'Sa.
You can see, I mean, Contract's clearing up this top side. Feels like he's trying to mitigate any further play. Take some resources off the map so Weiwei's not just getting everything.
I mean, Weibo are playing this early game fantastically right now. The thing is now.
所以说打到这里是真的没有翻盘点了，那也是没办法。我这主要是克里斯塔如果不能推线的话，就比较不舒服了。
哦，后面再一次太阳神剑2拉都拉到闪现进化一起逼了出来 ，FBI 这线还怎么对？
玩得很好，这波是利用了技能的 CD 哦，牛的 W 比雷欧娜的1还有9，我感觉他是卡着最后1秒直接顶上去的。 那个牛刚刚 W 感觉还差1-2秒，没办法把 AD 顶走。
对，而且这个冰川征服也在 CD 抢到2等，这下路已经在2分半不到的时间点 ，WBG 已经掌握了优势。
是的，这就是打线。
哇，而且其实看到 NRG 的打野 Contract， 他是下3滩全刷往上半部去靠的，所以在短短的这1分多钟里面，下路是孤立无援，微微甚至直接走过来了。
微微可能觉得对面有可能是自己开6鸟的，因为基本上。 你在韩服遇到的塔利亚只会是开6鸟，对。那这边走进来看到对面是蓝开，那就来约下。
啊，没想到下路还真的是孤立无援。那微微名牌走出来了，闪推知道 FBI 是没有闪现的，推在墙上。这是一波的 First Blood 给到了微微的口袋里面。赖特有拿到一个助攻 ，Ignore 现在一头牛。 还有闪现想要跑闪现，但是被 Crispy 给留住了。再往前一拉，打破了这个店家，回头锤到2个人，再把微微给顶到塔下。但是这波有一个壁咚把你给推出塔外，自己没扛到塔 ，Ignore 的人头落在了 Light 的口袋里。这一大波的兵线，下路没有接到 NRG 3分半，下路直接爆炸。
要被虐了，好，这就是野和打野的问题哦，因为他前面得先顾自己发育啊。 他不敢上开啊，因为他怕波比走进来扁他，他打不过啊。
对，但你在选出了野和需要刷的同时，
河蟹还被抢了，点了吧？这个 solo rank 我直接打15。
这下路又是一个需要你来靠、需要你来打3v3的一个阵容，就
对啊，
充满了一个冲突。
这就是为什么大家还是选功能型打野啊，就是你会跟线上起冲突啊。
那这波一波闪顶非常果断，知道他是没闪没进化的。 一条龙，一颗人头，只差一座塔了，再拿一座塔，他们这把算及格了。
但是我觉得要拿塔有点难，3线被推的情况下，
糟糕了，被一波的3甲防御塔已经被点掉，那准备是要跟这只老山羊说再见，还用甲克修死前多吸了一口，但 WBG 的3个人
头让给 AD，
慢慢的打，最后是 Light 已经 Killing Spree 302的战绩，这把是一个海妖的凯莎。
我觉得这把最大的问题应该是这个蓝宝没变。我觉得最大的问题是这个版本上路感觉，我觉得上路能 C 的最正常的英雄就是蓝宝的，就是蓝色方上路能 C 的最正常的英雄应该是蓝宝，就是他盲量，他上路可以稳定有优势来打团，去影响游戏。但是其他的上路我觉得都一般。那个盖伦不能算啊，那个黑科技不能算，
那个独门绝活，
那个不能算
是。但也确实，这看起来目前蓝宝在整个世界赛当中的胜率是偏高的，尤其他的出场率也偏低，因为他大多数场次都是被 ban 的。对。但以目前的经济领先来看的话 ，WBG 是真的不会给出任何的机会。从5分钟开始的经济就是一路往上慢慢的爬升哦。
又要继续来蹲上路了，因为这一定知道的啦，对面接不了龙。RG 这里只能去交换，正面已经拼不过去了。
真的要拖后的话，真的唯一能够抱持的希望就是在杰西魔剑叠好的那一刻。
是的，
或许还能够靠他的 poke 看能不能打一点希望出来。但 WBG 此时是同时在赚钱，在你来到强势期之前 ，WBG 是在持续的把伤口给撕裂的更开，
感觉是0，
没有什么机会。预示者还直接撞到了高地，没有人拆得掉。
撞2次哦，好削哦。
阿叶必须得回家 ，NRG 没有办法来防守这一条的巴龙 ，WBG 突然一波惊悚的开团，
好了，
吓得 NRG 满身大汗
，0.1%，
越来越低了
，0.1%，我不敢说0，
还是不敢讲不可能，
绝对是0.1%。
我只能说，这或许就是一个社会化的一个过程，从那个铁口直断到现在，不管多么绝境，都想保留。
我只能说，经历的事情多了，什么事情都有可能发生。
是这个一个人改变的速度非常快，有时候可能是要1年，有时候可能只需要1场比赛，
有时候只需要1个晚上。
是，哎呀，只能说那没办法了 ，NRG 看有没有真的就把那个0.1%再拿出来。
0.1%啊，其实应该是0.01%了，我感觉。
再更低一些。我这个大概就是什么？抽5星要歪。
歪是什么？
就是没有中到这个 PU。没有中到这个概率提升的角色
不太懂
没关系，反正就是不太可能，
没什么在抽的，
不太可能发生。
我自己抽都抽不中，可是我帮别人抽都很好，我也不知道为什么。这个是什么帮财运吗？
哎呦，你说就这个财永远不会在自己身上。
对啊，自己抽都很。
你玩打野的嘛，刚好很符合哦，
很符合吗？
很符合。这个线上经济都是给队友吃的，
是，好像也蛮合理的。
对，但 WBG 这刚看到的是 NRG 的一个中路尝试。没有成功，但现在反而是 The Shy 来断了对方的回城。Power Fox 追着 Chris 就是一顿的痛扁，但是自己的家里起火了，只能 TP 其中一边的门牙。这边是3个人在拆塔 ，NRG 全部的成员基本上都被流星钟给留住了。
好像有伏笔。
哎呦 ，Power Fox 这波的 TP 下来，则是被对方4个人给埋伏，刚下来就直接的是殒命。Contracts 这边则是被 Light 的闪现给跟上，一波伊卡西亚魔语，最后满层的电浆，不过人头是被小虎给插走，在门牙塔前只剩1个人的门牙，微微还在往前顶 ，Dogga 只剩1滴血，这时候 Light 冲了进去，准备要把全部人都给杀光，这是 WBG 双 C 的一波的秀，直接把对方给秀麻，要把这场比赛一律给收下。我们恭喜的是 WBG 结束了这场绝望式的比赛。
我感觉。
这选下来差不多了。
贾克斯打鳄鱼随便打，这阿奇尔打塔利亚随便打。
但最后看起来是真的想把塔利亚甩到打野去的。
卡萨丁哦，
应该是
不行吧？
亮好玩的。哇，杰西，
这是什么教学局吗？
你说上一把那个同 NRG 不会玩，我们教你一把。
但是这把比上一把好一点的情况下是左边不是波比，嘉文前面的强势没那么。
Now that you've got that lead, you don't need to take any more gambles, or you don't need to take any more risks. Just control the map well. You can see Chris roam. These mid laners love the champion. Gives you a lot of lane control, and also scales very well.
Reckless. That's how crazy it was.
I mean, yeah, a lot of roster changes went into this iteration. And to your point, though, what matters is peaking at the right time and what you can do with it now, because having to go through all of the wrist issues and everything.
Yeah, exactly. I think we should mention it that Oscar, of course, had a wrist issue. Oscar Rinnan in the top lane, if you're not familiar. Wonder had to come in actually for the season finals, where Fnatic made the finals, the grand finals of the season finals. But I think a lot of that was up the back of kind of finally seeing a Razor that we wanted to see.
Yeah, absolutely, and I feel like Noah stepped up in a big way. Noah Trimby were big playmakers throughout the whole playoffs, but it does call into a little bit of question about what type of Fnatic are we going to see, because they started the split so low, they had so many roster changes. The team that actually qualified is not the same as the team that is actually here, so as always, Fnatic is going to be fascinating.
It can never be not fascinating. It can never be easy. You know, I know Oscar, we know from his own post that he got here a little bit later as well, so you have to take that into account. But actually, everyone's dealing with things, so I hope that he's feeling
Where have your journeys taken you?
blade burns with holy fire. Easier to draw blood than staunch it. The best defense is a great defense!
A red sun rises.
Reporting for duty.
Nothing gets through!
Well played.
Round two! Taste the mana! What a rush! My client has the heart of a hero.
Need a bit more spice over here. We
Reporting for duty. Reporting for duty. Reporting for duty. Reporting for duty. To battle! Reporting for duty.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru au piano. Bravo et merci.
Remember this day, for you are graced with my presence.
Begin! My blade burns with holy fire!
YouTube Music 是个音乐应用程式，拥有等着你来探索的未知秘境。快不经意的炫耀新发现给你的朋友们吧！试试 YouTube Music Premium。
Hollow's End. I'm the one who is haunted.
Reporting for duty.
Taste the mana.
Job's done.
What a rush.
To battle! To battle! Reporting for duty.
Breathe it.
There will be peace in the Freljord. I will forge it.
When our homelands are restored.
Water to me.
Noxus will rise.
I'll never hold back. Stand ready.
Witness the strength of Noxus. Every soul shall serve. its true strength.
Will live on without you.
always rises to the top.
Water to me!
river of fate drowns the unworthy.
I will rule the Freljord.
Gone is the future.
back.
When our homelands are restored.
Shurima is where all paths converge.
enemies close and me closer.
Consorte, hear my name and go like straight. I bring